All right, you're welcome to today's class, and the course we are going to treat this afternoon is chemistry, and the topic we will continue with the solubility of what? Substances. In our last chemistry class, we introduced solubility of what? Substances. And before we continue in the subtopic we have for today, I want us to have a review of the assignment we gave last time. Review of the assignment. I think we did this. We solved some of the assignments, right? Did we? Okay. We didn't solve it at all. Okay. So we start. Okay, I can remember we solved mathematics. Okay, now we start with what? Chemistry review. So it's a review of our question of the assignment on solubility. That's what we do now. So after that, we will now continue with the topic. Now, I think I can remember giving you up to 10 questions, and I told you to solve these 10 questions. So we'll come out as usual, and let's see what we have and what we did. All right, let's start from the ladies first. Chinwaya, go to the board. Go to the board. Now let me detect. After you.
It's not mass.
It's not mass.
Yes.
How?
Like it's just.
Is what?
Theory.
Is it theory?
Yes, theory and mass.
Which one is not mass?
What question is
Do you know the question I want to give you? Do you know the question I want to give you? Because of what you said now, I'll give you calculation. You solve calculation. Oh yeah, Izu, start from number one. Oh yeah, Chinwa will start from calculation. Oh yeah, number one.
When a B star, when a B star is added to the clear solution of its salt, the crystal will not dissolve, and the solution left unchanged. That shows that the solution is A. Supersaturated, B. Concentrated, C. Unsaturated, D. Saturated.
So what's the answer?
Supersaturated.
Super saturated. So what is a super saturated solution?
A solution that contains as much solute as it can dissolve in the presence of undissolved.
Is that what I would define as super saturated solution? No. That is not it. Please go to your note, please.
Is a solution that contains more of the solute as it can normally hold at a particular temperature.
Good. Must there be presence of? Is there presence of undissolved in super saturated? In super saturated solution, there is no what? Undissolved. It's only saturated, because super saturated has already contains chai. Someone is lost. Yeah, chai. Ada, I cannot go back. Let's keep going, okay, with time. By time we'll keep going, because the idea is you keep moving forward. But I will drop the link. You listen to the lecture. Then gradually, by the time you solve one or two assignments, the picture will be clear. Okay? I don't want to start going back to what we did. It's much. Now, okay, what do we define as super saturated? I said that you know that super saturated. Sorry, you know that saturated solution. But don't switch off. Listen to what we are discussing. You know that for a saturated solution, that one at temperature is taking a saturated solution has taken the one it can carry. and is resting. Are you listening to me?
Yes.
A saturated solution has taken the one it can carry at that temperature in the presence of what? Undissolved what? Ones. But super saturated, that's why it's super. It contains more than, in fact, it takes in, it's a saturated solution takes more than what it can contain at what? Temperature. That means it has taken in everything that is presented to it. The solvent has taken more than what it can contain at that temperature. It's a super saturated what? Solution. Does it make sense? So the question says, let's go to the question again. It says, when a crystal was added to a clear solution of is what? Is what?
Salt.
Is salt. Is it salt?
It's salt.
Okay, the source. Is salt. The crystal did not dissolve. And the solution. Which one are you even answering? Number one. Okay, that thing is not. Anyway, let me not say the answer for now. When a crystal was added to a clear solution of its salt, the crystal did not dissolve, and the solution remained unchanged. This showed that the solution was what? But is it super saturated? Now, why did you choose saturated? Let's even go there. Why did you choose? It seems that I was busy answering the question for you. It seems that's I was trying to explain. Instead of allowing you to tell me the reason why you chose the answer you do. So now let's do the right thing. Tell us why you chose saturated. If I start from the first option, tell us what happened. Explain each of the options for us. That's how to study what, how to answer, understand OBJ questions. So let's go to option A. So tell us about option A. What do you think about it? Is it the answer? Why is it the answer? Then if it's not the answer, why is not the answer? Yeah.
It is not the answer.
Why?
Because the crystal was added up into a clear solution, not a saturated solution. And P is concentrated. It is not the answer.
Because of what?
Because the solute
Oh yeah, now I'm listening. Chimoya, tell us. Obodogia, tell us. Oh yeah, which one is the answer? Start from A. Tell us why. If A, start from A to B. Fast. Let's do that things.
Super saturated is it contains more solutes and it can dissolve at that temperature. Then concentrated is the quantity of the solute that is present in a given solution. That is the quantity of the solute. So concentration is not the answer.
Is that concentration?
Concentrated. So the crystal is not concentrated. Then unsaturated, they take up more solutes and it can contain.
Unsaturated than it can contain. What are you saying?
Unsaturated, they take up more solutes. Then saturated is that they are stable, they are at equilibrium.
What is there? What are they?
The crystal that was added in the clear solution of the salt, then they are stable.
So what's the answer?
Saturated.
So even if you add in that solution, the solution has already taken more than it can take. So if you add it, it remains the way it is. There will be no change. So the answer is what? Saturated. Good. Number 2. So if you correct yourself now. Number 2 says what? Read number 2.
A supersaturated solution is said to contain A. As much solute as it can dissolve at that temperature. B. More solute than it can dissolve at that temperature. C. As much solute as it can dissolve at that temperature in the presence of undissolved solute. D. More solute than it can dissolve at that temperature in the presence of undissolved solute.
So we start from the beginning. Break down the options and tell us which one, if it's the answer, why is the answer. If it's not the answer, why is not the answer.
A. As much solute as it can dissolve at that temperature. Supersaturated solution, it does not contain as much solute.
It
does not contain much solute.
What are you saying? Go and read the definition of supersaturated solution for us.
It contains more of the solute than it can normally hold at that temperature or particular temperature.
So then what are you now telling us in the option A?
What I'm saying is that it does not contain as much.
So go back to the division now.
They contain more of the solute than it can normally hold at that temperature.
Then you come here and option A is what?
As much solute as it can dissolve at that temperature.
Do you really understand what we are doing? You speak as if you don't understand what you are doing. I said that pick option A. Tell us, the first thing you say is option A is the answer. Yeah? Then if it's the answer, tell us why is the answer. Then if option B is not the answer, tell us it is not the answer. This is why it's not the answer. That's what I ask here since. Option A is what? Is it the answer? Yes or no?
No.
Then why is not the answer? Simple thing. So why is not the answer? That's the question.
Because it does not contain much solute.
Which one?
Supersaturated. That is the option A is as much solute as it can dissolve at that temperature.
Hey, how do I put this enough to make people understand what you are doing? This thing you are doing is a very important aspect of your studying and answering exam question. But you seem not to have a glimpse of what I'm doing. Can you stand up, please? Stand up. I said you have 4 options there. Do you understand super solution? No, you don't. You don't understand it. What is supersaturated solution? What comes to your mind? What's supersaturated solution first? What is it?
Supersaturated solution is a solution that contains more solute than it can hold at that temperature.
Do you understand? Do you even know the meaning of what you're saying now?
Yes.
So what do you mean of what you're saying?
You bring water and salt, and now add the salt inside the water. As you're adding the salt inside the water, it will get to how do I say it? So you get to a point whereby the salt you are adding is more than the water, but it will still contain that salt that you are adding inside the water.
So now answer this question. Option A is what?
As much solute as it can dissolve at that temperature.
Is that the answer?
No.
Why is not the answer?
Because it will get to a point whereby
you don't know. Bingo.
More solute than it can dissolve at that temperature.
Is that the answer?
Yes.
So why is it the answer?
Because like I explained earlier, if you're adding the salt inside the water, it will get to a point whereby the salt will be more than the water, but it will still hold the salt.
Since C is what?
As much solute as it can dissolve at that temperature in the presence of undissolved solute.
Is that the answer?
No.
Why?
Because supersaturated solution does not contain undissolved solute. It only contains dissolved.
The inco?
More solute than it can hold, more solute than it can dissolve at that temperature in the presence of undissolved solute.
So, is it the answer? Why?
The sentence is in.
So, why is B the answer? Oh, sorry, why is A not the answer?
Because as you're adding the salt in the water, for example, I put it in a cup, and they're adding the salt in the water, there will reach a point whereby the salt, as in it's in now, the cup the follows nutrients in your man dissolve.
Is it Igbo language and is it your problem now? You are switching to Igbo language. Is that your problem? Let me know where you should coming from. Is that your problem now?
Yes.
My God. Anyway, Igbo language is not bad, but make better is well to understand what you are doing. Am I communicating? All right. Sit down. The answer is actually what? B. That B actually defines supersaturated solution, that it contains more solute than it can do what? Dissolve. It contains it, but having contained such, there's no undissolved one again. That is, it actually dissolved more than it can do what? Take at that particular what? Temperature. Am I communicating? That is a supersaturated solution, and it's not stable. Once you put a crystal, there will be a what? There will be a what? There will be a what? Is it precipitation or crystallization? Which one?
Crystallization.
Is it precipitation or crystallization? Which one?
Crystallization.
All right, let's continue. That's the answer. Then, next question is what?
A substance X.
I follow it.
A substance X is.
Stop. Hey, okay, come. Come and start number 3 for us on the board. Fast. Take marker. Okay. No, read that question first. Sorry, just read the question first. Let's see.
The substance X is isomorphous with another substance R. When a tiny crystal X is added into a supersaturated solution of R. X dissolves in the solution. B. Crystals of R are precipitated. C. There is no observable change. D. R and X react to generate heat.
Generate what?
To generate heat.
Heat. Okay. Is that all?
Yeah.
So what's the answer? Start from A. A says what? After A says what? Turn. Face your students. Option A says what?
X dissolves in the solution.
S
Dissolves in the solution.
dissolves in the what? Solution. So is that the answer? Is that the answer? Huh? You don't know. Chinwe, is that the answer? Is A the answer? Why? Because what happened?
substance X is the solvent and the substance I is the solute, and it's the solute that is being dissolved inside the solvent.
What are you saying? You say what? Say it again.
I said X does not dissolve in the solution because X is the solvent and R is the solute, and it's the solute that is being added, that is being dissolved inside. So
You are talking badash. Badash. How can you call supersaturated solution a solvent? How can you call this substance S a solvent? This is chemical crime. Chemistry crime. You committed chemistry crime. Didn't I teach you what a solvent is and a solute is and a solution? How can you call this thing solvent? What did you even call solvent here, sir? X? Is that what I taught you? Please, after class, try to read your notes very well. Read your materials. If you open an assignment, try to understand some key words in everything you are doing. You don't miss up things, please. There's no solvent there. Okay, you're asking me that. I gave you assignments. You went home with assignments. You saw one big word, isomorphous. You didn't bother to check it up. And you are back to the class to give to solve assignment. You are asking me as isomorphous. It's not funny. It's funny, right? You are given an assignment in class. You saw one big word there, isomorphous. Then you went home. You don't understand the meaning of isomorphous. And you are doing assignment. How then did you do the assignment? When you don't understand the meaning of what? Isomorphous. What should be the first thing to do? Look for the meaning. That's why it's assignment. I intentionally put it there. So you can look for the meaning yourself. Now you are back asking me, sir, what is the meaning of isomorphous? Had it been you are here, I just gave you the question direct, and tell you to supply me the answer. That's why you can ask me this question. I can now say, okay. But I give it as over 1 week now. You didn't bother to check the meaning of isomorphous. Is it right? Answer. Is it right? So because of that, I will not tell you the meaning of isomorphous. Go and find it out for yourself. Come back and tell me what isomorphous is. I will keep that question pending. You guys should go back, find the meaning of isomorphous, come back and tell me. I gave it to you to go and check as assignment, so you can come back and discuss with me. You are back and asking me what is isomorphous. I won't tell you. You go back and do proper research and come back. Then we'll talk about it. Is that fair enough? Good. That's how to learn. Now, let's move to the next question. What's the next question then? Please keep that. Remind us in our next class. I'm going to get with another. You get it? Good. Remind us in our next class about this assignment that has isomorphous in it.
So it's written or latent.
Is what?
It's written or latent.
It's written or what?
Latent.
So that means the two of them are related by appearance, by structure, right? Good. You guys will go now. Then continue. So X and Y, the two crystals, there are two crystals. The two of them are what? Two substances are what? Related. In fact, you can say that they are the same in a way. Am I communicating? Now, continue. So, is A the answer? Okay, you say you don't know. Is A the answer? Explain why A is not the answer. You don't know. Then B, is B the answer? What is option B?
Crystals of R are precipitated. Crystals of R are precipitated.
Is that the answer?
Yes.
Why? Why do you say why is that the answer? Why?
The two crystals, the two solids, and later.
Remember, Y is already a solution in solution form, right? The Y is already a super saturated what solution. Remember, then X is isomorphous with Y, and you are adding X into that super saturated solution. What will happen? That's the question. You say crystal of what?
Of R precipitated.
Is it R and Y or S and R and S?
X.
Sorry, I was saying Y. Now, what crystal will be precipitated? For the question, for the option.
Crystals of R.
Which one is the super saturated solution?
R.
Okay, S was added.
Yes.
So, now, option C, income.
There is no observation change.
There's no
Observation change.
why. Can you tell me a solution where that C is applied?
C.
Where option C can happen? What type of solution that option C can happen? Saturated solution. True or false? It's true because it's what? More what? Stable. There's equilibrium there. True or false? Yeah, continue.
Then D, R and X react to generate.
But if you hit it, will there be a change?
Yes.
Did I teach you that in saturated solution?
Yes.
So if you hit it, what will happen? What will happen?
This thing will.
The equilibrium will do what? Change, right?
Yes.
Now, but if you just add the crystal, will it change?
No.
Continue. So that's why C is that C?
D.
What did C say?
There is no observation change.
That's why C is not the answer because we are not talking about saturated what solution. The C A C A. I don't mean we are talking about saturated solution. Then C will be the answer because there will be no change. True or false? D option D says what?
R and X react to generate heat.
That one is a lie. True or false? Because they didn't even mention what R is and what X is. So how would they know that they will react and generate heat? It's not when you know what they are. That's when you talk about whether they can generate heat or not. So the answer is what? B. Because remember I told you. Remember in our last class, I said that I told you that if you add if you have a super saturated solution of a particular word, are you listening?
Yes.
I told you that if you have a super saturated solution of a substance and you put the same substance in that solution, there will be what? You know that super saturated solution is what? Is not balanced, is unstable. So once you put it, what will happen? That solution will do what? We crystallize what? We do what? Crystallize what? Out. That's what happened in super saturated solution. So that's why option B is the what? Is the answer. Is it clear? Good. Oh yeah, I go. Next question. Chiwendo, I go there. Next question. Is it calculation?
Yes.
Okay. All right. So, okay, since you are done, so tell us what you did. Start from the beginning. Start from the question.
12 grams of potassium trioxide chlorate 5 we are added to 40 grams of water and heated to dissolve all the solid. As the solution cools, crystals of potassium trioxide 5 started forming at 66 degrees centigrade. The solubility of potassium trioxide 5 at 66 degrees centigrade is there.
So what is this in euros?
asked us to look for the solubility of potassium triisochlorate 5 at 66 degrees Celsius.
So where did you get this formula from? Tell us now. Where did you get it from?
I browsed it.
Okay, you browse the formula.
Yes.
And what is formula?
Yes.
Do you understand this formula?
Yes.
What is that?
The solubility. This
It's
one
what?
is the solute, which is 12 grams of potassium, and this solvent is 40, which this 12 grams was added into it times 100. Then you now put that 12, that is the solute, which is this one, times 100, and the solvent, which is 40. You now calculate it, you now get
that. Okay. Let me solve. Let's solve. Do you have any contrary view? Did you solve it? You don't solve it. You see, you did not use your assessment share. So why did you solve this one? You could not solve it. Okay. I'm not killing this note. I want to solve something else with a different method. Then after we compare the two of them, am I together? Are we together? Good. Now read the question again.
12 grams of potassium triisochlorate 5.
12 grams of what?
Potassium triisochlorate 5. We are added to 40 grams of water.
To what?
40 grams of water. And heated to dissolve all the solid. As the solution cools, crystals of potassium triisochlorate 5 started forming at 66 degrees centigrade. The solubility of potassium triisochlorate 5 at 66 degrees centigrade is therefore dash.
Okay. Now, let's look at this question again. The solute is what? Potassium chlorate, 12 grams. Were added to what? So the solvent is what? 40 grams of what? Water. Now, what is solubility? First of all, what is solubility? What is solubility? First of all, what is solubility? What is solubility?
Solute and solvent.
Salt and what?
Solvent.
Salt and what?
Solvent.
Is solubility. What are you saying? You are defining solution for me. What is solubility? What is solubility? What did I teach you? What is solubility?
Is the maximum amount of solute in moles or gram that can saturate 1 gm of the solvent at that particular temperature.
So solubility of a substance at a particular temperature is maximum amount of the what?
Solute.
The substance, right?
Yes.
That can do what? That
can saturate 1 gm cube of the
solvent at that what?
Particular
temperature. Now, what did I say about 1 gram of water is what?
1 centimeter cube.
Is what?
1 centimeter.
1 centimeter cube, right? Now that means 40 gram of water is what? Is what?
X.
Is what?
40 centimeters.
You want to push character, Shay?
No.
Hey.
40
what?
Centimeter.
Are you following? We are told that 12 grams of potassium chlorate was dissolved in 40 grams of water, and it was what? It was what? Cooled, right?
Yes.
Cooled. It was cooled, right?
Yes.
At what?
66 degrees centigrade.
So what happened?
Then the solubility of potassium triisochlorate.
No, when it was cooled, what happened?
Crystals of Then the solubility of the gastric is defined as 60 degrees centigrade.
Good. Now look at this now. This is 1 gram. So this is what 40 cm cube. Now we say that solubility is what the amount in what 1 what
GM
1 what
GM.
dm cube, right? Now 12 gram in 1 dm cube. You have what here? There are 12 gram in what? 40 what? cm cube, right?
Yes.
So if there are 12 gram in 40 centimeter cube, so what will it be in? Change this centimeter cube to dm cube. Remember that 1000 cm cube is what? 1 dm cube, right? Therefore, 40 cm cube is what? X. X is what? 40 cm cube over what? 1000 cm cube times what? So this is what? 4 over what? 100 what? dm cube. Is it clear? Is it clear? Okay, what did you define? You put down the definition of solubility I gave. Why did you put it down?
I didn't get everything you said. You are rushing.
I rushed and you kept quiet. We say that solubility of a substance at a particular temperature is defined as the amount of a substance, whether in gram or in mole. In gram or in mole, that will saturate 1 dm cube of water at that temperature. Is water in that definition of solvents? Is water in that the definition we gave us solvents? That will saturate what?
1 GM cube of the solvent.
Please put that water, replace that water, because that solvent can be, it must not be water. Am I communicating? Unless you are defining solubility in water, that's when water can come in there. Do you understand? Solvent must not be water. You know, I said a substance. I didn't say in water. Am I communicating? So solubility of a substance is what? At a particular temperature is the amount, which amount in gram or mole that can saturate what? 1 dm cube of a what? Solvent. Now look up here. This is a law that for water, 1 gram is what? Is taken as what? 1 cm cube for water. So if that is the case, that means 40 gram of water is what? 40 cm cube. Are you okay now? But are you aware that 1 dm cube is 1000 cm cube? Are you aware? Are you aware? So convert this 40 cm cube to dm cube. That's what you did there. And got what? 4 over 100 what? dm cube. Is that clear? Is that clear? So that means this is 12 gram in what? In what? 1 over what? 4 over what? 100 what? GM cube. Is it clear now? Is it clear? This thing now has been converted to what? dm cube. We have 12 gram in what? 4 over 100 dm cube of what? Water. Is it clear? Is it clear? Are you sure? You make me shout. If I ask questions, talk, please. I shout too much. If you don't say it's not clear. Don't keep quiet. Is it clear?
Yes.
Good. Is it clear?
Yes.
Is it clear? Good. Now, since it 12, that's what you're doing is coming down. I know we are rushing to, so you not be ashamed here. Come down. Do that thing you're doing. Try to understand what you're doing now. Well, even if you feel it will laugh at you, it doesn't matter. You are looking at your book, but we are missing something here. It's wrong. If I stop solving anything, if I call you, fail it, fine, sit down and learn it. You trying to solve something here, then you are missing something here. You bought you went online and brought a formula. You don't even know the meaning of the formula. I'm trying to solve something else so you can understand it. You are looking at your book. It's wrong. This formula you brought, do you know the meaning? You don't know. I'm solving something here. I'm telling you how to solve this from the first principle so you understand it. Leave the formula. I don't like people carrying formula up and down without even knowing where they came from. This is what I'm solving here now. So I want to check whether this thing formula is I don't know how they got it, but I don't work with those things. I try working things from what? First what? Principle. Am I communicating? So try to understand it. But if someone is asking solubility, there are some questions you will see. This thing will not work. True of us. But if you know how it came, how to solve it from the scratch, you can solve any question in solubility. You remember, let me start from the beginning. They say the question say 12 grams will dissolve in 40 grams of what? Water. And for it to start crystallizing, means that it got saturated, that the water got saturated at what? 66 what? Degrees Celsius. That's the meaning. So that is the maximum water can take at what? So what means that 40 grams of water, the maximum amount of potassium trihydrochloride 5, 40 grams of water can take at 66 degrees Celsius is what? 12 grams. That's meaning. That's meaning. So we want to know the solubility. Now, we are told that 12 grams was dissolved in what? 40 grams of water. But solubility says that the maximum amount, solubility is the maximum amount of a solute, which can be in gram or mole, that can saturate 1 dm cube of what? Water. And I told you here in our last class that 1 gram of water is for water alone, no, is equal to what? 1 cm cube. If 1 gram of water is equal to 1 cm cube, that means 40 grams of water is equal to what? 40 what? Cm cube. But the solubility says in 1 dm cube. So you convert this to what? Dm cube. Am I communicating? But you know that 1 dm cube is 1,000 what? Cm cube. So if 1 dm cube is 1,000 cm, that's what we need here. If 1 dm cube is 1,000 cm cube, therefore 40 cm cube should be what? X. Is it clear? We find the 40 cm cube in dm cube, right? Are you following me? That's what we did and got 40 over 1,000. 1 0 will cancel 1 0. We got 4 over what? 100 what? Dm cube. So that means 12 grams of this potassium trihydrochloride 5 was dissolved in what? 4 over 100 what? Dm cube of water. Now, but somebody say that it must be in 1 what? Dm cube. So how much of it can dissolve in 1 Dm cube? So we look for it in what? 1 what? So if 12 grams was dissolved in 4 over 100 Dm cube, stand up, okay? Stand up. You are sleeping. If 12 grams was dissolved in 400 over 100 Dm cube, how many grams of this potassium chloride would dissolve in 1 Dm cube? We do what? Cross multiply. So that means S is now equal to what? 12 grams. Oh yeah. Times what? 1 Dm cube. Over what? 4 over what? 100 what? Dm cube. Remember the rule of fraction. Because of this division, this 100 will do what? Come up. 2 of us. Are you aware? So if 100 comes up, that means that X is now equal to what? 12 grams times what? This 100 will come up. Times what? 100. Over what? 4. Over what? 4. This is 100 what? Dm cube, right? Sorry, Dm cube is still here. Down. Dm cube is still here. Down. Are we together? So we have 4 divided 12 is what? Is what? 3. 4 divided 3 is what? 3. 3 times 100 is what? 300 gram per what? DM cube. Is there anything we are missing here? This is 40 cm cube, right? 100 cm cube, 1000 cm cube is equal to what? 1 DM cube. 40 cm cube is what to what? X. This is what? 40 over what? 100. This will go down. We have 4 over what? 100. Now, 12 gram in 4 over 100 DM cube. How many of this will be in 1 DM cube? So this is 12 gram times what? 1 DM cube over 4 over what? 100, right? Now this will come up. We have 12 times 100 over what? 4. 4. The answer is what? Is that an option like that, this question? So what's the option there?
33, 10, 20, 30.
Then why am I getting 300? 300 gram per DM. Why am I getting 300? Let me check where it came from, where the error came from. I've actually gone through the question and the options, and I have I have question marks on the even options of the question and the question, because from what I can solve, I'm getting 300, but I'm seeing 30 without unit, as I said before now. So I think what we'll do is I'll put asterisk in this question. I'll go back to it. The formula Chiwandu posted used here. It may be correct too. I'm not casting it, but at least I should be able to prove where the formula came from. So that's why I cannot continue with this, because I will keep it pending. We'll come back to it again when I'm sure that the question is not wrong. But I've never seen a where solubility has no unit. Sometimes if they don't want to put the unit in the option, you can see they can ask you the solubility in, maybe let's assume they'll ask something like this: what is solubility of so in mole per DM cube? In such case, now they are already put that mole per DM cube in the question. In the option, they may not put it again. They may just write out the what numbers, figures, without putting the units. But here now, they are nothing like you, and we know that 40 gram is what? 40 what? cm cube. And moving this 40 cm cube to DM cube, we have what? 40 over what? 1000 what? DM cube, which is certain as saying 4 over what? 100 what? DM cube. And if you have 12 gram in what? 4 over what? 100 what? DM cube. Then by definition of what? So it should be in what? 1 what? DM cube. And if you look for the amount that will be dissolving, that will be saturate 1 DM cube, it will give us what? 300 gram per what? DM cube. So I don't understand where that 30 came from and where the 100 in the formula came from. That's where I have issue. This is difficult. This is what I know as what? Solubility. So I'm not comfortable with that options and that question. But I don't want to say whether it's wrong or not. But I'm not comfortable with it. That's all I can say. Because I know that from the definition of solubility, that this is what it is. Even from what we did in textbooks, different textbooks, different solubility, that's what it is. But for that one not to have a unit, I don't know. And I don't know. And if you want to move this 300 gram per DM cube to what? Mole per DM cube. You simply find the number of molar mass of what? Potassium triiodochloride 5, which is what? 1 what? 122.5, right? Because we have 39 plus 35.5, which is 74.5, plus 48, which is 48, 74, 40, 114, 114, 122. 122.5 is correct. Now, if you want to find the molar, the solubility in mole per dm³, you divide it by the molar mass, which is 122.5 gram per mole. So if you divide 300 by 122.5, what's the answer? Divide 300 by 122.5, what's the answer? Don't worry, you can punch your calculator here. Let me fast. Punch it. What's the answer? 300 divided by 122.5. Huh? 2.44 mole per what? dm³. This is the solubility in mole per dm³. 2.44 mole per dm³. This is what I know as solubility. I don't know where, the question, I don't know. This is what I know. So I think we'll leave it at that for now. Then if there is any other better information, I can always go back and talk about it, okay? But the basic thing is for you to understand how to solve questions in what? Solubility. By the time we solve more questions in solubility, you understand why I insist on this. Because that is what we define solubility as. That is what we define what? Solubility as. Am I communicating? So it should be 300 gram per dm³, not 30 without unit. It doesn't make sense. Even you said, doesn't make sense to you? So it doesn't make sense to me. So that's why I will insist on this until I see a better. Maybe I will study that formula Chinwe used. Let me even know where the formula came from and why they are saying that solubility is solute over solvent times 100. Doesn't make sense. What is solute over solvent? Solute in what sense? Solvent in what sense? Is it concentration or the weight? In what sense? It makes no sense to me. So I will stop here for now. Let's move to the next question, please. Fast. Next question.
5 cm³ of saturated solution of sodium chloride.
5 what?
cm³.
Come see. I follow you. Is it making sense to you? Good. Oh yeah.
5 cm³ of saturated solution of sodium chloride at 30 degrees Celsius gave on careful evaporation 1.95.
Did you do that one? Number what?
By 5.
Did you do it? I come and solve it fast. Fast. Come and solve it for us. Call the question first now before you start solving. Okay, don't worry. Chinwe will call for us. Chinwe, call.
5 cm³ of saturated solution of sodium chloride at 30 degrees Celsius gave on careful evaporation 1.95 gram of solid salt. The solubility of sodium chloride at 30 degrees Celsius is dash.
Again, read well. Yeah.
5
words.
5 cm³ of saturated solution of sodium chloride at 30 degrees Celsius gave on careful evaporation 1.95 gram of solid salt. The solubility of sodium chloride at 30 degrees Celsius is H.
Okay, yeah. Remember the solution, the volume of the solution is what?
Then sodium is 23 and chlorine is 35.5.
All right, let me solve this question. Please call the question again, please.
5 cm³ of saturated solution of sodium chloride.
So 5 cm³ of what? Sodium what?
30 degrees Celsius.
At what?
30 degrees.
Gave
on careful evaporation.
Pause. Do you see how I say Do you see how I stay at the board? On the board. You don't stay like this. You stay what? Like this, okay? Good. If the board is divided into two like this, so don't start writing here. Start writing from here. Then, as you finish writing here, you come here, this side. So you don't block what? Any body. I'm not complicating. Now, you said that the 5 cm cube of saturated what? Solution of sodium chloride at what? 30 degree stage is what? So if you heat it, all the water will do what? Leave. What will remain is only what? Sodium chloride, right? Right? And the weight is what?
1.95 grams.
So 1.95 gram of sodium chloride remains, right?
Yes.
Okay.
Then the solubility of NaCl at 30 degrees Celsius.
So they want to take the solubility of what? Sodium chloride at what?
30.
Remember the definition of solubility. The maximum amount of solute or substance, right? That can saturate 1 dm cube, 1 dm cube of a what? Solvent at that particular what? Temperature. Now look at it. The temperature in question here is what? 30 cm cube. Now, but they told us that this solution is what? Saturated. That's what they told us, right? What it means is that is the amount 5 cm cube of the entire solution is what? 5 what? Cm cube. That 5 cm cube is only what? Saturated. That is the maximum it can take. The maximum it can contain is what? 1.95 cm cube of what? Sodium chloride. Is that clear? Now that means, and when they now heat it, what remains after the whole water left is what? 1.95 cm gram, 1.95 gram cm, 1.95 gram of what? Sodium chloride remain. That means the amount of sodium chloride inside that saturated solution is actually what? 1.95. True of us. Good. Remember, if you heat sodium chloride in solution, water will disappear. It remains sodium chloride. If the weight of sodium chloride that remains is 1.95 gram, that means the actual amount of sodium chloride that is in that saturated solution before it was evaporated has always been what? 1.95 what? Gram. So if that is the case, what it means is that we have 1.95 gram of what? Sodium chloride in what? In what? 5 cm cube what? Solution, right? Do you understand this one I did now? Now, what is the amount of sodium chloride in gram we can have in 1 dm cube? But remember that 1 dm cube is 1000 cm cube, right? Right? So if 1 dm cube, for it to be solubility, it must be in 1 dm cube, remember? So we will look for it in 1 dm cube. But you know that 1 dm cube is certain as what? 1000 cm cube. So any place you see 1 dm cube, are you following? Please don't use because you are not there and knock off. Put that seat down. Concentrate. Don't switch off because you are not there. Please, it's the wrong attitude. Even if you are not there, I've mentioned a lot of things about solubility here since. You can still follow up if you are interested in it. Please don't switch off and say afterward I wasn't there. Therefore, let me stop listening. No, don't do that. It's not good. Follow up what I'm saying. So for it to be solubility, it must be in 1 dm cube, right? So if we look for, we know that we'll check the amount that will be in what? 1 dm cube. But 1 dm cube is how many cm cube?
1000 cm.
So instead of writing 1 dm cube here, because of this unit, we write what?
1000 cm.
So how many sodium chloride X will be in what? 1000 what? Cm cube. Is this not what I did in the other one? Good. So let's find X. X is what? 1.95 gram times what? 1000 cm cube over what? 5 cm cube. What's the answer? Cm cube cancel cm cube. What's the answer? 5 divided 1000 is 200. Then 200 times 1.95 is 390. because 2 times 1.95 is 3.9. Because 1.95 into 2 is what? 3.9. So you now add the 2 remaining 0. That the decimal point will eat 1 0. 1 0 will remain, right? It becomes, if that decimal point between 3 and 9 eat 1 0, it will become 39, right? Then you add the remaining 0, it become what? 390. So the answer here is what? 390 what? Gram. So there are 390 gram of sodium chloride in 1 dm cube, right? So this is in 1 what? dm cube, right? This is solubility of what? Sodium chloride in 1 dm cube. But they gave us, they want it in mole per dm cube, right? Yes. Right? Yes. So how do we find it in mole per dm cube? We convert this to mole per dm cube. Just divide with the what? Molar mass. Because number of moles is what? Reactive mass over what? Molar mass. Remember, number of moles is what? Reactive mass over molar mass. Just simply convert this 390 gram to what? Moles. By dividing by the molar mass of sodium chloride. What is the molar mass of sodium chloride? Huh? What is the molar mass of sodium chloride? Huh? What are the component elements of sodium chloride? So what are their relative atomic masses? Sodium is what? Chlorine is what? So add 2 of them. 35.5 plus 23 is what? 58.5. So molar mass of sodium chloride is what? 58.5 what? Gram per what? Mole. Good. Gram per what? Mole. This is the unit of molar mass. So now the solubility in mole per dm cube is now equal to what? Therefore, solubility of sodium chloride in mole per what? Is equal to what? 390 gram per what? Divided by what? 58.5 what? Gram per mole. Gram will cancel what? Gram. This mole will come up, right? 390 divided by 58.5 is what? 390 divided by 58.5 is what? What's the answer? Fast. 6 point what?
6.
No, just
6.
so 6.67, right? Yes. I forget it now. So it's not about the what? 6.67 mole per what? Yeah. This is the what? Solubility of what? Sodium chloride at 30 degrees. Is that the answer?
Yes.
Is that the one you tick?
Yes.
Yeah. You not solve it and wait and tick answer. Is it not what we did in the other one? That one they gave 30 and she got one formula. I don't know where it came from. It's not Gail. Which one you did not understand? From the beginning. Hey. And you're here, you keep quiet. Please, please, let me say this, please. Calculation is step by step. It's very wrong for you to sit down in a class. Your teacher move a step, you don't understand, you keep quiet. Is it right? It's not right. So you're telling me now to start all over again, all these things that I'm shouting since. It's wrong. If I take a step, each of these things are linked to the previous step. If I take a step you don't understand, stop me and ask questions. That is calculation for you. Not to keep quiet after shouting and coming down to the answer. You tell me you didn't understand from the beginning. It's funny. No, it's funny. It's not fair. It's strength. I use it to talk. Is it fair? It's not fair now. You don't keep quiet. Once I say this is this and this is this, I don't understand why this is this. Say, excuse me, sir. Sir, I don't understand where this thing came from. Open the one to Nyansa, it seems, sir. I didn't understand from the beginning. Oh, I can't go back. I'm even tired of shouting. I can't go back. Don't know what is monomass. But you relate to atomic mass. Monomass of a substance is what? Monomass of a substance is the what? Mass of 1 mole of that substance. Is the mass of what? 1 mole of what? That substance. Now, 1 mole of a substance. 1 mole of, hello? Listen carefully. 1 mole of sodium chloride is simply the mass of 1 mole of sodium plus mass of 1 mole of what? So 1 mass of 1 mole of sodium is just simply just get the electric atomic mass of what? Chlorine, sodium, and add it to electric atomic mass of what? Chlorine, which is what? What is electric atomic mass of sodium? Huh? You don't know which textbook do you use in chemistry? You go back. You have not read it there.
What it means? I read it before.
Huh?
I read it before, but I forget.
Okay, no problem. We'll still do it anyway in other class, in the other center. You know, it's not the center topic we are doing here that we are doing it. We'll still do it there anyway. We'll get there, but don't be afraid. But just know that the atomic mass of sodium is what? 23. That of chlorine is what? 35.5. So if you want to check the molar mass of sodium chloride, you simply add the two of them, you get 58.5 gram per mole. That's what we used to divide this 39 gram per dm cube. Is it clear? Is it Juku? How do I help you now? Besides, you start from the beginning. Do you understand this thing? Do you understand what you mean by 5 cm cube of sodium chloride in solution at 30 degrees Celsius? Do you understand what you mean by when you say that? Three of us were here when we did the experiment. When we now added, we said that the salt was added to water, and we keep adding until it becomes what? Saturated, and you heat it. We are not the one scattering the calculation here. When where Chinwe was taking the heat, you are shining. She was taking the heat. I'm surprised that now you say that you don't even remember again what we are saying that time. You are the one. You were champion that day. Now she took all the heat. Eh? You are the one solving it, telling us that this is. That's why I let you know where to come from again. But let's see what you can do. Remember that in that experiment now we added what? We say okay, sodium was added, salt was added in water until it became what? Saturated, that you cannot dissolve again. And it was heated, two of us, and the solvent did what? Left. And the solute was left. Now, if you take salt solution and heat it to water left, all the water left the solution, you have only 20 grams of salt remaining as solid. Now let me ask you, and if that salt doesn't decompose in your heat, it's just there, let me ask you, how many gram, let's say what was remained in the evaporating dish is 5 grams in fact. Now let me ask you, how many grams of the salt was in that solution before? I said, if you get a solution, you know what's a solution, right? What is a solution? Something you're looking for is a solution. In what?
That has contained a solid
A solution is solid plus solvent. Now, if you get a solid and put a solvent, it will dissolve. Is that not a solution? You see, I will stop using this chair. It makes you to lose control. Stand up. Sit here. Sit on this one. Sit here. So you can coordinate. Get this seat and sit well. Sit erect like a sit the hands so you can go in our water. Now we say I now you know what is a solution, right? Now if I now get a solution and give you, you hit it and all the water left. Maybe it's a solution of sodium chloride. You hit here and all the water left, right? And what you remain in the evaporating dish is 5 grams of the water solid, right? Now I'm not asking you, what is the amount of that solid that was actually in that solution before you hit it? Good. That is the same what? 5 grams. Maria, it's not true. Now you are told here that a solution of sodium chloride is 5 cm cube. The volume is 5 cm cube. But when they now hit it and all the water in the solution evaporated, what is remaining there is 1.95 grams of sodium chloride. What is the amount of sodium chloride that was actually in that solution before hitting? Huh? Huh? Yeah, gas. Huh? You have answered this question here now. Why keep it quiet again? Now let me come again. Whatever would tell me a solution. What is a solution? What is a solute? Give me an example of a solute first. Let me even know whether you understand what I'm talking about here, sis. In what? In solid form. What's a solvent? Example. Then if you put sodium chloride inside that water, it will dissolve it, right? What will be formed? Solution, not water. What will be formed? Solution will be formed. Now, I'm not asking you. When you now get that solution, let's assume you were not told the amount of sodium chloride that was added in that solution. And you get that solution and heat it until the water disappears. And you check the amount of sodium chloride remaining in the dish. And it gives you 2 grams. I just say again, the amount of sodium chloride that was in the solution before heating it. It's 2 grams. Now look at this thing. That's again we have 5 cm cube of sodium chloride solution saturated, which means that is the amount it can take, right? You now heat that saturated solution. Water now leaves this solution. What will remain there is 1.95 grams of sodium chloride. In that original saturated solution before heating, get the amount of sodium chloride in here. 1.95. Is it clear? That means actually we have 1.95 grams of sodium chloride in 5 cm cube of the solution. 3 of us, the saturated what? Solution. But this is just in 5 cm cube. Before you can turn it to solubility, you must find the amount in 1 dm cube. Oria, is that not in the definition? So if 1.95 grams of sodium chloride is in 5 cm cube, how many will be in 1 dm cube? We put 1,000 here because 1 dm cube is 1,000 cm cube. So it can be the same unit without that cm cube. So how many will now be in 1,000 cm cube? How many now? You cross multiply. Is that not what I see on the board? You have 1.95 gram times what? 1000 cm cube. All over what? 5 cm cube. Oh yeah. You divide that, you now get that the solubility. Because whatever you get now is actually the solubility of what? Sodium chloride in that solution. Is 390 gram per what? dm cube. This is solubility in gram per dm cube. But the question is China in mole per what? dm cube. And I'm checking that before to convert, if you want to convert, that's why they gave you the relative atomic mass of sodium and chlorine instead as 23 and what? Because they want you to calculate the molar mass of what? Sodium chloride. What is it? I divide exactly 390 to get the amount in mole, the solution, the solubility in mole per what? dm cube. That's why we divided it and got what? 6.67 mole per what? dm cube. Is it clear now? Huh? Are you sure? I keep quiet because we don't want me to get tired. Are you sure it's clear? Kamsi, is it clear? Are you sure it's clear? Eh? Kamsi will solve the next question for us. They even know whether what we are doing here is clear, even though she wasn't in the class when we treated this. Don't be afraid. Go and solve it. If you all this is you listen to me talking for the past 1 hour, go and do it on the board for us. Let me know whether you are following. Okay. So now, the answer is what? 6.60 mole per dm cube, right? Now let me think so that Kamsi can come and solve the next video for us. Kamsi, Oya, go to the board. Call the next question for Kamsi.
3.06 gram of potassium trioxochloride.
Huh?
It's 3.06 gram of a sample of potassium trioxochloride 5.
I copy it. Huh? I come. You know this.
3.06 gram of a sample of potassium trichloride 5. Trioxochloride 5. Was required to make a saturated solution with 10 centimeter cube of water.
Is that all?
I'm waiting for that.
Okay.
Saturated solution.
10 centimeter cube of water at 25 degrees Celsius. The solubility of the salt at 25 degrees Celsius is 25 degrees Celsius is A 5.0 mole per dm cube, B 3.0 mole per dm cube, C 2.5 mole per dm cube, D 1.0 mole per dm cube.
You have succeeded in cancelling in putting the units. Please remember that you always put the units as you're doing your calculation, so that when you are done, you know exactly the unit to cancel that. This thing now is 306 grams of potassium chloride in what? In how many dm cube of water? Or in how many dm cube solution? How many dm cube solution is it? Huh? Put it now. It's okay. Either in 1 dm cube or per dm cube, it's okay. Yeah. So what is that? What is the meaning of this 306 gram per dm cube? What did you calculate now? This is the solubility of this potassium chloride in gram per dm cube now. But is the answer? Where did they want the answer?
In mole per dm.
Convert it to mole per dm cube now. Well, what did I say about monomass? Huh? What did I say about how to calculate monomass? Huh? And so, but if you want to convert this 306 gram to gram per dm cube to mole per dm cube, what would you do? You divide by what? By what? By the monomass of potassium triiodocarbonate, potassium triiodochlorate 5 now. Did I say it here? I can't see. Now, so now calculate the monomass of potassium triiodochlorate 5. Calculate it from the formula. They're looking at you. See the formula there. So you don't know the formula of what you wrote. KClO3. If you get, then calculate the monomass of it. You don't know what? The relative atomic mass. Potassium is 39. Chlorine is 35.5. Oxygen is what on there? See, you're supposed to know oxygen now. 16. It's not 16. So how many oxygen atoms are there? So what will you do to that 16? Good. Then add up. What is it? Speak out. One word. What's the unit? What's the unit of monomass? Gram per mole. Continue. So what's the answer now? Of course, gram. See, the gram will cancel gram. Can't you see it? Then mole, that mole there will come up to become mole per dm cube. Then divide 306 by 122.5. What's the answer? Achimo, what's the answer? What's the answer?
2.497.
2.497 what? Mole per what? Dm cube. Which is equivalent, make it 2.5. 2.5 mole per what? Dm cube. Well, what is in the option?
2.5.
So the answer is what? But you were afraid before. In Nigeria. Is it clear? Is it clear? Is it clear? Are you sure? Chinwe, is it clear? Good. Now let's go to the next question. So Chinwe, sub number 7. Be fast, no time. Call it out. So she can write.
When 50 cm cube of a saturated solution of sugar, open brackets.
You can just call it slowly so she can write. Call it slowly and loud.
When 50 cm cube of a saturated solution of sugar, open bracket, molar mass 3.42 gram per mole, close the bracket, at 40 degrees Celsius, was evaporated to dryness, comma. 3.42 gram of the dry solid was obtained. The solubility of sugar at 40 degrees Celsius is A. 10.0 mole per gm cube, B. 7.0 mole per gm cube, C. 3.5 mole per gm cube, D. 2.0 mole per gm cube.
Is that all?
Yes.
I solve fast. Solve and let us know what we did. Please correct this thing, please. An error, please. Molar mass is 342.0 gram, not 3.42 gram per mole. Molar mass is 342.0 gram per mole, not 3.42 gram per mole. Then the mass, the weight, the mass of the what is it called again? The sugar is 34.2 gram, not 3.42 gram. Please correct the mistake, please. All right, continue. All right, so Chinwaya, explain what you did first. Explain what you did. Please increase your
34.2 grams is in 50 cm cube, and you know that 1 dm cube is 1000 cm cube. So you write down 1000 cm cube, then you're looking for the mass. Then you now cross multiply 1000 cm cube times 34.2 gram divided by 50 cm cube. Then cm cube cancel cm cube. You multiply 1000 times 34.2 gram. It will give you 60. It will give you 684 gram per gm cube. Then
multiply and divide.
Yes, and divide.
By what?
By 50. It will give you 684 gram per gm cube. And the molar mass that was given to us was 342.0 gram per mole. So the solubility of the sugar that they asked us to find is this 684 gram per gm cube divided by the molar mass that was given. It's now 2 mole per gm.
Is it clear? Is it clear? Is it clear? Come see. Good. Good. All right, question number 8. Come on, solve question number 8. Come on, solve question number 8 for us. Are you done? I explain what you did.
The solubility of moles per dm cube
Of what?
mole per dm cube 20 gram of copper sulfate dissolves in 10 gram of water at 13 degrees Celsius. You find solubility. Which is 20
So this thing you did here, what is this thing you did here? I don't know what you did there.
mass of mass times
Times what? What is 100? From where? What's 100? Can you come and try this thing? Fast. Stay there. Come and try this fast. Fast. Read the question first so you can understand what you're solving.
The solubility in a mole of DMQ of 20 gram of copper sulfate dissolved in 100 gram of water at 180 degrees C.
So when you're not solving, let me know so you can explain what you did. It seems easy to go and count it, doesn't know how. Come back, count it. Stand there. Stand close to I saw. If Chima fails it, three of you will stand there. Nobody is sitting down today until the end of this lecture. Explain what you saw, Chima. Let your voice, please increase your volume. Let's hear your voice, please. Let's hear what you are saying.
You said the solubility of water DMQ of 20 gram of copper sulfate dissolved in 100 gram of water at 180 degrees Celsius, and 1 gram is 1 cm. So you look for 100 gram in cm. So you cross multiply 100 gram times 1 cm divided by 1 gram will give you 100 cm cube. Then you look for it in dm cube, and 1 dm cube is 1000 cm cube. So 100 cm cube, you don't know what it is, so you put it as x. So 100 cm cube times 1 dm cube divided by 1000 cm cube will give you 0.1 dm cube. And this thing.
Wait, did you understand what she did up to this level? It's true. So where did you not understand? Where? Explain what you did.
I cross multiplied 100 times 1 cm cube divided by 1 gram will give you 100
Is it clear now?
And you know that number mole over molar mass. Number of moles over molar mass. As in,
what are you saying? N is what?
N number of moles.
M is what?
The mass.
I say molar mass. Can continue.
And the mass they give us is 20 gram. And the molar mass of copper sulfate is 159.5 gram per mole. So if you divide 20 gram by 159.5 gram per mole, it will give you 0.125 gram.
So what is gram still in there?
Mole.
Uh-huh.
So now they ask us to look for the solubility in mole per gm cube.
Okay.
So this 0.125 mole divided by this 0.1 gm cube is now give you 1.25 mole per gm cube.
Is it clear now? Is it clear now? Huh? Are you sure? And let's solve the next question. Question number what? Can't say good understand. Call. Did you copy number 9 question? I can't see. Solve it now. Oh yeah. Solve it. Oh yeah. Call it and solve fast. Fast. Go and sit down. Call it. Loud out. Okay, I'm coming. I call the question and solve now. You know, on Alright, I solve it. I said call the question. Have you got the question?
The solubility of copper
Number what?
tetra
Copper tetra oxide sulfate 6. I continue.
in 75 gram, 100 gram of water at 100 degrees C, and 25 gram, 100 gram of water at 30 degrees C. What mass of the salt will crystallize if 50 gram of copper tetra was sulfate 6 saturated solution at 100 degrees C? We are cooled at 30 degrees.
That's all, man. Fast. So this question, Kansi could not solve it. Izu could not solve it. Even our star girl for today could not solve it. Who is our star girl for today? Izu. Who is our star girl for today? So our star girl couldn't solve it. Star girl Alpha. Okay, now let me solve it. It's getting interesting. So this one is technical. That's why I want to solve it. There's something else here I want to solve. Okay, so just listen critically so you can understand it. Okay, just listen so you can do what understand it. Let's solve this question. Please, I want you to listen carefully. Before I can solve this question, there's something I want to tell you. Remember, we've been talking about, Kamsi, listen. We are about to do something else now that confuses students. That is confusing students. It's not all the time that you will change to CM cube, okay? Sometimes, let me give you an example now. If you are given, let's assume you are given 1 gram of salt, 1 gram of sodium chloride, for example. Now, if you are told to add 1 gram of sodium chloride, in what? Let's say 20 gram of water. 20 gram of water. What will be formed? This is what? Solute, right? Right? And this is what? This is what? Solvent, right? And what will form is what? Sodium chloride what? Solution. Now let me ask a question. What is the weight of this sodium chloride solution? If 1 gram of sodium chloride is added to 20 gram of water, what will be the weight of the sodium chloride solution? Chiwendu. If 1 gram of sodium chloride is added to 20 gram of water, what will be the weight of the sodium chloride solution formed?
20 gram.
20 gram. You? 21 gram. Good. Is what? Be careful about this. 21 what? Gram. So if you add 1 gram of sodium chloride to 20 gram of water, the solution formed, the weight is what? Will be what? 21 what? Gram. This nice I described now is what I will use to answer that question. So, do you now understand it now? Because they are both in what? Gram and in what? Gram. Is it clear? Now, let's use this now to answer that question. Come and stand here so you can read the question. So I can pick the question you are reading. Come and stand here and read the question for us. Read the question. The question says,
The solubility of
louder, come closer.
the solubility of copper tetraoxosulfate 6 in 75 gram in 100 gram of water.
Start afresh. You know the question well.
The solubility of copper tetraoxosulfate 6 in 75 gram.
No, it's not true. Is it in or is? Is.
75 gram. Is 75 gram in 100 gram of water. Is 75 gram. 100 gram of water. At 100 degrees C.
It's 5.71. 35.71.
35 what?
0.71.
0.71. Good. Now, let's keep that one aside. So there's something I want to do. This question, well, you already disjointed. Let me read it myself. I'm not making meaning from what you're reading. Come see. Don't worry, you're not yet familiar with all these terms. Don't worry, with time you will. The question says, write it again. The question says, the solubility of copper 2 sulfate, copper 2 tetraoxosulfate 6 is 75 gram in 100 gram of water at 100 degrees Celsius, and 25 gram in 100 gram of water at 30 degrees Celsius. The question says, what mass of salt will crystallize if 50 gram of copper 2 sulfate saturated at 100 degrees Celsius we are cooled to what? 30 what? Degrees Celsius. Now, this 175 gram is the entire is the entire what? Solution, right? Of copper sulfate that was at what? 100 degrees Celsius. Am I communicating? Now, if you have this here now, if you have 175 gram of copper sulfate, this is the copper sulfate solution. 175 gram of copper sulfate solution. Inside this 175 gram, we have 75 what? Gram of what? Copper sulfate, right? So in summary, we have 75 gram of what? Copper sulfate. In what? 175 gram of what? Copper sulfate what? Solution. Does it make sense to you? Does it make sense? This 100 gram is water alone, no? Hope you know. Are you aware? This 100 gram is for what? Is water what? Alone. So, but 75 gram dissolved in 100 gram of water will form what gram of solution? 175 gram of what? Solution. So there are 75 gram of copper as salt in what? 175 gram of copper what? Copper sulfate what? Solution. There are 75 gram of copper sulfate as a solute. In 175 gram of copper sulfate what? Solution, not water. Now, is it clear? Now, if we have 75 gram of copper sulfate salt in 175 gram of copper sulfate solution, remember the 50 gram, we are working at 100 degrees Celsius now. That 50 gram will contain how many gram of what? 50 gram of copper sulfate solution, saturated solution, will contain how many gram of copper salt? How many will be in what? 50 gram of what? Copper sulfate what? Solution. Look at that 50 gram. Is it copper solute or copper solution? Solution. Is it clear? So if we have copper, ordinary copper salt in 175 gram of what? Copper sulfate solution. How many gram of copper salt would we have in 50 gram of copper sulfate solution? You do what? You do what? Cross multiply. Are you following? So this one now become what? 75 gram times what? 50 gram. All over what? 175 gram. The answer is what? 21 point what? 4 2 what? 8 what? Gram. Do you know what it means? That in that 50 gram copper sulfate solution, we have 21.428 gram of what? Copper sulfate solute. Is it clear? Is it clear? Is it clear? Good. Now, at 100 degrees Celsius, what you have inside it, the solution is what? Is what? 21.428 gram of what? Copper sulfate what? Solute. Good. Now, this is what you have at this point. What do you think we will have in this at this temperature? 25 degrees Celsius. Remember they say 30 degrees Celsius. Remember they say that it will cool down to what? 30 what? Degrees Celsius. Now if you cool it down to 30 degrees Celsius, what do you think will happen here? Do the same thing you did here for 25 degrees, for 25 grams. So remember the total weight of the solution here is what? 125 gram, right? So if you have 25 gram of the copper solute, copper sulfate solute, and 125 gram of copper sulfate solute, how many will we have in 50 gram of copper sulfate solute? What's the answer?
10.
Huh?
10.
No, it can be 10. Check well. If we have 25 gram, a 25 gram of copper sulfate, a 125 gram of copper sulfate solution, how many copper sulfate solute will we have in 50 gram of copper sulfate solution?
10.
Is it 10? Are you sure? Okay, good. Okay, let me do it. Let me take it as what? 10 gram, right? So we have Write this so I can clean. But do you understand what I'm doing? We are done with 100 degrees Celsius. We want to do with what? What happened at 30 degrees Celsius? After we subtract and get the one that did what? Crystallize what? Out. Is it clear? Okay. This question is technical. You need to understand the principle behind solubility before you can answer this question. That's why I'm taking my time to solve it. So I can clean here, right? I will work. After I will work for what? 30 what? Good. So let me clean here. So let me work. What happens at 30 what? At 30 what? Degrees what? Celsius. So let me work on what happened at 30 degrees Celsius. At 30 degrees Celsius, the entire solution is what gram? 125 gram. It's not true. So the entire copper 2 surface solution is saturated solution is what? 125 gram. Now, but if 25 gram of copper, if 25 gram of copper sulfate what? Salts or solutes of copper sulfate solute is in what? 125 gram of what? Good. Copper sulfate what? Solution. I'm happy you guys are following up now. So how many gram of copper sulfate salts, so solutes, will be in what? 50 gram of what? Copper sulfate what? Solution. So S is now what? 25 gram times what? 50 gram over what? 125 gram. The answer is what? 10 gram. Now, at 100 degrees Celsius, the weight of copper sulfate, the mass of copper sulfate solute there is what? That dissolve is what? 21.428. But at 30, 21 point what? 428. 21 point what? Can I clean? Yes. Have you seen this one? Yes. This second, what happened at 30 degrees Celsius? Yes. Now let me clean so I can write it well. Is that right? I will do that. There, this black marker that was there before. Where is it? Okay. Now here at the copper surface solute present that dissolve here is what? 21.428. Make it to 2 decimal places. 43 gram, right? Now at 30 degrees Celsius, what amount is dissolved? 10 gram. 10 what? Gram. Now, if we cool down from 100 degrees Celsius to 30 degrees Celsius, the amount that will crystallize is the difference of this and from this, true of us. So the amount that will crystallize out is the amount that couldn't dissolve again, right? 21.43 gram minus 10 gram is what? 11.43. Huh? 11.43. 11 point what? 11.43. Wait. Please wait. I notice a mistake here. If you put salt in water, if you put salt in water and you cool down salt solution to a lower concentration, did the water leave? Did the salt leave? No. Did it leave? This is the same 175 gram in 100, 175 gram in 100. Am I communicating? Now, if you find 25, if you find it in 50 gram, and the 50 gram solution was cooled, the one we have at hand was cooled to 30 degrees Celsius. Will that 50 gram change? So the entire solution, will it change? Will it change? It should remain what? The same, right? This thing that happened here, this 125 by I wrote here is an error. It might have happened from here to here, because this is an experiment that was done somewhere. They have checked it and noticed what happens. But we are doing our own fresh experiment. Hope you know. Their own must have crystallized. But our own, we don't know amount that will crystallize yet. So we will not go and use their own words. 125 grams. We work with you have 50 grams of solution in your hand now. 50 grams of solution in your hand. And cool it to 30 degrees Celsius. If you move from 50 grams solution, if you cool it down to lower temperature, your 50 grams you are holding cannot change. True of us. It will not change. Now, but we don't know what it will result, because we have not even done the experiment. So this one should be, this one is in order, but this is where I have issues. At this 125 grams, we should also find it like here should be, if there are 75 grams, if there are 25 grams in 1 watt, 75 gram solution. Now, how many will be in 50 watts gram? Are we together? How many should be in watts? 50 gram. Look at this place. Here, when you move from here to here, of course, for you to remain 125 gram in 100 gram, something must crystallize out of this solution for it to happen. Am I communicating? Or personal, or probably they not even subject it to that crystallization level. They only just realize that this in 100, this has this concentration, this solubility in 100 gram at 100 degrees Celsius, and this has this 30 degrees at what? This 25 gram in what? 100 gram as what? 30 degrees what? Celsius. Now, when you have this 25 gram in 75 gram, 25 gram in 175 gram, how many will be in 50 gram? What should be here? What should be here? As against 10 gram, you should get something else here. Seven point what? So here is what? 7.142 what? Gram. 140, or simply say 7.14 what? Gram. Is it clear? Is it clear? Is it clear? Okay, where are you confused?
This is I wrote 50 grams, and the X is 50. How is it 50 grams?
No, you know we are working with 50 grams of solution. We are working with what? 50 grams of what? Copper 2 what? Sulfate what? Solution. We are the one we are cooling is 50 grams. So that's what you're working with. They just gave you this to give you instance of what happens when this is dissolved in this. Is it clear? Now we're working here to what? To 1.43. Then here should what? Here is what? 7.14. Then subtract 7.14 from 21.43. What's the answer? 14.26 gram. 14.26 gram. So here is 14.26 gram. So now the weight that will crystallize out of the solution is what? 14.26 gram. Is it clear? This minus this give what? 14.26 what? Gram. This may be a very long step. If you understand this, I'm going to solve it again with a shorter step. I wanted to use that shorter step before. When I said 175 gram is 125 gram, how many 50 gram will you what? Remember that when I did it, I stopped. I want to go back to that formula. It's shorter, but I want to go through this length for you to understand something. Now, if you agree with me, I don't know what it is. The answer here is 14.3. So here should be what? 14.3 gram. That's the answer. But let's leave it like that. I want to go through that shorter part and see what you will get. If that shorter part still give us the same answer, then this is the what? Answer. If you give us this previous one we got here, 11 point something, then that means that this question is what? The option here is what? Wrong. Let me follow the shorter part. Why I leave it that short part, this will expose a lot of things for you. In the process of passing through this part, didn't you learn something new? Now, but let me now go to shorter part. Let's see what we get. Are you done? Are you done? Are you done writing down? Please do. Please, here should be what? 25 gram in what? 175 gram. S should not be what in what? 50 gram. Everything else is now what? 7.14. What it means is that at this 30 degrees Celsius, there are 7.14 gram of what? Copper 2 sulfate remaining in the what? Solution. Is it clear? Is it clear? Now, because the solution did not evaporate. Did it? Now, with that now, we subtract 21.4, we subtract 7.14 from 21.43 and got what? 14.26. Approximately what? 14.13. But I want to go to the shorter part. Let's see what we will get. Are we set? Please, fast. Let's do the shorter one. Let's see what we will get. So, listen carefully. Listen carefully. I want to solve this question now using shorter part. Then we'll then compare it to the one that is easy for us to understand. But I intentionally passed through these steps for a reason. Okay? Now, let me now go to. I wanted to use that shorter. If you are listening to me, when I started solving this question, I said before 175 gram. The total weight here is what? 175 gram is what? Cool down to what? 125 gram. What would 50 gram be cool down to what? Can you remember what I said it and stopped? Decided to go through this means. Now let me go back to that one again. It's shorter, it's straightforward. Now look at it here. So you cannot compare the one you want to use when you are faced with a question like this. Decide that on your own. Now let's solve the shorter one. At 100 degrees Celsius, right? Here is what? 75 gram of copper 2 sulfate. 75 what? Gram of what? Copper what? 2 sulfate in what? 100 gram of what? Water. True or false? So this will give what? 175 gram of what? Copper 2 sulfate what? Solution. Now, but when it's cooled down to 30 degrees Celsius, I follow you. You have 25 gram of what? In what? Water. So this gives us 125 what? Gram of copper 2 sulfate what? Solution. Is it clear? Now, if 175 gram of copper 2 sulfate solution was cooled to what? To 30 degrees to give 125 gram of what? Copper 2 sulfate solution. Now, 50 gram of copper 2 sulfate solution, saturated solution, will be cooled down to what? X. Find X. X is now what to what? 50 gram times what? 1 to 5 gram. Are you following? Because you do what? Cross multiply, right? All over what? All over what? 1 what? 75 gram, right? All over what? 175 what? Gram. What's the answer?
35 points.
35 point what?
71.
71 what? Gram. 35 point what? 71 gram. Is it clear? That means if 175 gram of carbonated solvent solution was cooled down to 30 to yield 1 to 5 gram of carbonated solvent solution, that means 50 gram will yield what?
35.71.
If you cool down 50 gram, it will form what? 35.71 gram. Now, if you want to know the amount that left this solution, you do what? Subtract. Now, subtract 35.71 gram from 50 gram. What's the answer?
14.28.
Minus 35.71 gram. The answer is what?
14.28.
14 point. What is the last digit there? After 8.
5.
Please don't throw 5 away like that. Start from 5 and approximate and stop at one decimal place. You get what?
14.3.
14.3 gram. Is it clear? Is it the same thing? Is it the same thing? But this one is short as shade. This one is short as shade. Is it clear? Do you need further explanation on this? Have you seen why I said that this is technical? You need to understand a lot of things before you can solve the question. So this is the word's answer. And from the options, the answer is what? The answer is what? Which option? D. Is it D or C? D. The answer is what? D. 14 point what? 3 gram. So if we are done, let's go to the next question. I think that should be the last question on this assignment. Oh yeah, our target for the day. Izu was the star boy, you know, something. He was just scattering everything. Yeah, Chichi was like this. Chichi was receiving lashes. Pass. She never cried, okay, Izu. She never cried on Saturday. On a Saturday, what is your What is your with man? Now she's target. Can't see anybody what that. Can't see the confused. So we keep struggling. We keep working hard. We keep improving. That's the purpose of what we are doing. You keep doing what? Improving. All right. So score the question, please. Let's hear the question.
The solubility in mole per dm cube of 20.2 gram of potassium chloride. Potassium chloride.
Which one is that? Potassium trioxonitrate 5. So.
Potassium trioxonitrate 5. Dissolved in 100 gram of water at room temperature is A 0.10, B 0.20, C 1.00, D 2.00.
I solve it. Alright, I explain what you did.
1 gram is 1 cm cube. Then root for 100 gram is cm cube, which is 100 cm cube. Then we convert 100 cm cube to dm cube, and 1 dm cube is 1000 cm cube. So 100 cm cube, we don't know what it is in gm cube, so we cross multiply. Then 100 cm cube times 1 gm cube divided by 1000 cm cube. Cm cube, you cancel cm cube. And if 100 times 1 divided by 1000, we give us 0.1 gm cube. Then number of moles is equals to mass over molar mass, and the molar mass of potassium trioxynitrate 5 is 101 gram per mole. So our mass is 20.2 gram and our molar mass is 101 gram per mole. If gram cancel gram, many moles. So 20.2 divided by 101 to give us 0.2 mole. Then 0.2 mole divided by 0.1 gm cube to give us 2 mole per gm cube.
Is it clear? Is it clear? Is it clear? All right, so I think that is the end for the assignment review on chemistry. Review of assignment of chemistry. Now, I want to call out an assignment again on the same chemistry. You write it down now. You do it at home. In our next chemistry class, we present it. Now, take down this assignment, please. Take down this assignment. All right, can you see the graph on the board, the curve on the board? Now, let's use this to answer this question. The question says, from the diagram, draw the diagram first, then I will take the question. From the diagram below, comma, find the amount of solutes. Find the amount of solute deposited when 200 cm cube. Find the amount of solute deposited when 200 cm cube of the solution is cooled from 55 degrees Celsius to 40 degrees Celsius. A, 0.10 mole. B, 0.20 mole. C, 0.01 mole. D, 0.02 mole. Second question. If 24.4 gram of lead 2, if 24.4 gram of lead 2 trioxynitrate 5, if 22, all in bracket 2. No, it's not PB2.
Okay, PB.
Just PB. Then it is here NO3 in bracket. Then 2 will be outside. If 24.4 gram of lead 2 trioxynitrate 5 were dissolved in 42 gram of distilled water, if 24.4 gram of lead 2 trioxynitrate 5 were dissolved in 42 gram of distilled water at 20 degrees Celsius, comma, calculate the solubility of the solute in gram per dm cube.
42 grams of distilled water.
Let me start afresh. If 24.4 grams of lead-2 triisonitrate 5 were dissolved in 42 grams of distilled water at 20 degrees Celsius, calculate the solubility of the solute in gram per dm cube. Calculate the solubility of the solute in gram per dm cube. Option A, 5.801. 5.801. Option B, 58.100. 58.100. Option C, 581.00. 581.00. Option D, 0.581. 0.581. Are we there? Good. I think we'll stop here for the chemistry assignment. Let me stop at 2. Okay? Because I'm going to give an assignment on another subject. I think we have spent too much time on chemistry today, 3 of us. I want us to do physics before 6 p.m. Okay? We'll do physics now, but before that, what's time? 5:09 p.m. I want you to stress yourself for like 10 minutes. In 10 minutes time, we'll come back and enter physics. I'll start with assignment on physics. Then after assignment on physics, I'll teach. So on teaching until 6 p.m. we dismiss, okay? All right, so let's stop here for now for chemistry.